we have new series, and I will try to explain what is exactly the gradient descent is, and we will look at directional derivatives and how it's related to gradient descent. But I want to first start with a multivariate calculus and how do we really do it. So if we had a 1D graph and we wanted to, I mean, it's two-dimensional graph, but our input space is one-dimensional, which is x0. And let's say we want to find the derivative at this point. And how did we do this? We just, um, oh, sorry. We have this. We want to find the derivative at this point, x0. So derivative simply means the slope at this point. Slope at this point. So it goes like this and like this angle we want to find. And how do we do it? We have x0 and then we have x0 plus h, and this distance is h. This distance is h, and this corresponds to fx0, and this corresponds to fx plus h. And how can we find the angle in this here? If it was just a simple line, if it was just a line, not a curve, then we would just do fx plus h minus, oh sorry, fx plus h minus fx divided by h, right? Divided by h. It would give us exactly the slope because it's just a line if it was a line, but it's not a line, it's a curve. So so we have to do something else. What we should do, so we should exploit the fact that as h goes to 0, this thing here gets closer to a line, and we take this fact and we write limit h goes to 0 fx plus h minus fx divided by h. And as h goes to 0, this gets closer to the slope of the line. So it goes, it gets closer to 0. This h, the gap. So like this, and right here, this is more like a line than this is. That's the idea in one-dimensional um, input space. What about we have two-dimensional input space? Then it's obvious that we will need a three-dimensional graph to plot input space with two variables. Let's say in the first case our function, let's say, was fx squared, but now we have f equals to x squared y, f squared y. So we have two variables. And how do we calculate this? When we calculate with respect to x, it means that we treat y as constant, and when we take derivative with respect to y, we treat x as constant. And you can see it here. It's a very good three-dimensional graph, and this is our input space xy, and And it simply means like when we take derivative with respect to x, this is what it means. It means f x plus h, y stays the same, plus, oh sorry, minus fxy divided by h, and of course limit h goes to 0. And what does it mean? It means we want to find the change of f with respect to x, and how a small change in x affects f. And in this case, we are purely moving in the x direction. Purely moving in the x direction. And in that case, you see that we take only one point in y. For example, let's say we take this here. So it's obvious that y is some, for example, 5. Y is a constant. That's why we treat y as a constant, because we are moving in the purely in the x direction, and it becomes like this. Purely in the x direction. And for example, we want to find the slope at this point. We want to find the slope at this point, and or at this point. It looks like a global maximum, so it will be like fx with respect to x. I mean, so this will be 0 here. And with the same rule, we can find the slope, if we treat y as a constant, and then we find what is the slope when we move purely in the direction of x, and how does it affect the function, and what's the slope in this line. And with the same analogy, when we take its derivative with respect to y, we say limit goes to h0, then f x stays same, y plus h minus f x y divided by h. And what does it mean? X is constant. X is constant, and we just go in this direction. And actually, we don't need this; it's already shown here. We go purely in the y direction. That's why with x doesn't change. That's why it's constant. And when we go, if we want to find the slope in any of these points on the graph, on this graph, then we'll have to calculate this. So this is the point. This is the point where we want to calculate the slope of this slope to this point. For example, this is any point x0, y0, and yes, then at this point the slope of this point will equal to f f y. Yeah. So this is the idea of multivariate derivative. In the next video, we will talk about directional derivative and what is it.